Hello friends, this is Eli with Mystic Circuits. Today we've got another tutorial video on building one of our favorite DIY kits, the 0 HP AND gate / VCA. Of the four that are currently available, I would say that this one is the most difficult in the building department, just because it has the most parts. Some of the parts you need to put in the correct direction, and so if you're not used to checking for that sort of thing, you might easily miss it. I would say that the Vactrol VCAs are the hardest to get working from the calibration standpoint, because there is a part that you need to adjust in order to get it to work right. But just from pure volume of building and amount of soldering that you have to do, this is the hardest. So if you haven't built anything else before, if you haven't built any of the 0 HP modules, if you're just starting out with DIY, I highly suggest to start with the OR gate. It's another kit that's available through our website. It's very simple. It's very much, I would encourage anyone who is trying to get into building their own synthesizer, it's a great place to start. There's literally, 10 parts you got to do on the whole thing, probably less. I can't count. So also, if you are new to soldering at all, I suggest checking out our first tutorial video on just soldering basics. I go over some of my techniques. I solder a lot. It doesn't mean that I do everything perfectly or that I don't make mistakes. It just means that I have a lot more to teach. So, and even if you've been soldering for a minute as well, you might learn something from there. I don't know. So I'd suggest to go check that out first. Anyways, let's dive in. This is our 0 HP AND gate. This is the kit that you would get from our website. So first thing we're going to want to do, because, I stuff these all myself by hand, and sometimes mistakes are made. So let's just go ahead, check out that everything's there. Sometimes, especially with these parts have painter's tape on them, right? Sometimes they will get stuck on the inside of the bag, so we just want to look in there. Looks good. If you're at all unsure, just shake it out a little bit more. No? Alright. So let's see. We've got two of these sort of silver bags. One of them is a squarish one, and one of them is a long one. This one has the LED inside, and this one has the optocoupler chip that does the legwork in this design. We'll put those to the side. We've got our acrylic backing, beautiful acrylic laser cut backing. So we got that. We have the circuit board. Obviously, we can't do anything without a circuit board, so that's looking good. These are the jacks where signals come in and out of your module. You need 4 of those, so we've got 4. We have our capacitor. There's only one of these, and it's just a little orange dot with these 2 silver legs coming off. So we only need one. That looks good. Now there's 3 different sort of resistor groups in here, and you'll see that one of them is a single resistor labeled 10K. One of them is 2 resistors, a pair of resistors labeled 1M. And the third is 3 resistors, a triplet of resistors labeled 1K. All of those designators are just different values of resistance that you would find on the circuit board. Of course, I made an error. This 1K right here is actually supposed to be a 10K, so we'll deal with that first. But you can see that the rest of these little footprints are all labeled either 1K or 1M. That stands for kilo ohm, and that stands for mega ohm. So we'll just be aware. Count these out, make sure you have the right amount. That's 1 10K, 2 1 megs, and 3 1Ks. And as I said before, we'll start with the 10K just to make sure we know that it's in the right place, since, again, it is not labeled correctly on the board. So we've got our 1 meg. You just can pull the painter's tape, pull the little paper edges right off, and right here is where it's going to come in. If you look carefully, you'll notice this circle and then a little line connecting these 2 holes. The line indicates that you connect your resistor between these holes and not, from here to there, from here to there, some, crazy going across the board or something. It's quite logical. You usually want to connect the holes that are connected with this little line. The circle it usually denotes that you put the body of the resistor there. It's not important. Don't worry about the circle, but just to show you, we bend the resistor over and the body is on, let me get that to focus, body's on one side and the wire is on the other. Usually, if you want everything to look pretty, I mean, I don't bother with this too much, but the body of the resistor goes where that little circle is. Again, if you do this backwards, it won't break anything. So if you didn't catch that, I just literally, I put the legs of the resistor, let's do that again in slow motion, right? So I have my resistor, it's bent over, I'm just grabbing it by the body, and then put one hole there, one leg in that hole. You hold it down, and then you just bend these legs over. Now, I usually try to avoid, so like let's say if I had a leg going this way, and it's covering up one of these other holes that's pretty close by. I'm trying to focus this. I'm going to be focusing the camera a lot because I get a lot closer for these. The circuit board's ready for its close-up. So you see this leg is kind of covering that other hole. That can be a bit dangerous, as when you're applying solder to this hole, sometimes it'll travel up the leg and then get some solder on that hole and possibly plug this other hole with solder, and that's just a pain. We don't want to deal with that. So what I usually try to do is I keep the legs off to the side where they're not interfering with any other solder, or if they are, you know, maybe touching something, like it's pretty far away. So like something like this, I would say is most likely fine because you're applying solder over here and it shouldn't be able to go really that far. But just to be on the safe side, just keep the legs somehow away from the other solder holes. Now, focus again. I'm going to turn up the heat on my iron. And first thing we always want to do when we're starting out is we tin the tip. You just let the, oh, forgot to mention, we also have these standoffs. Yeah, so these connect the circuit board to the acrylic backing. There should be 4 little white doohickeys in this plastic bag. We'll leave that for the last. Back to soldering. Just kind of touch your solder to the tip of the iron, and you'll see this nice shiny bead start to form. And now we've got this big, robust belly of solder. I'm going to go ahead and just tap that. I'll just flick it onto the, really hard to do this while watching my screen, but you just flick it on the sponge there, clean it off. Either that or you can use your dry solder cleaner. You can see how dirty my desk is right now. So again, tin it again. And basically just do this until you've got a nice shiny coat on the outside. Shows a shiny coat shows that you've been feeding your iron the right kind of stuff. So we look here, just try and get a shot of the iron. You know, the tip is still a little bit dull, but the side is what we're mostly working with anyway, so shouldn't be too much of a problem. Now when we're soldering the board, we want to apply the edge of the iron to the spot we're putting the solder. So we heat up the entire area, then we just kiss the solder right onto it. So what we're not trying to do is to just stick the tip of the iron on and then apply solder there. What we also don't want to do is we don't want to just put solder on our iron. Like solder isn't like glue, right? So you don't just stick the solder onto your iron and then stick it on the hole, right? What you want is to heat up the area that's going to be receiving the solder, and then you just touch the solder to the edge and it'll flow right onto where the heat is. You'll see me do that a bunch of times, so don't worry if you didn't understand it right away. You'll get the hang of it. Solder's just, you gotta practice. It's like riding a bike, you gotta practice. So what I just did there, used my snippy snip tool to remove those legs, get it nice and close, and if we take a look at the joint, we'll see this nice Hershey's Kiss of solder sticking out. Look at the other side. You can see that the solder went all the way through the hole, making a nice bond with the leg of the resistor. You can even see a little tiny bit of solder underneath there. It's not, you don't have to check everything this intensely, but I'm just trying to give you a really good picture of what a good solder joint looks like. And if you want to see what a bad solder joint looks like, watch my video on the basics of soldering. I go into it in much more detail. All right, so you know what? Actually, let's do the 1 megs because there's only 2 of them. Just pull off all of the paper stuff, all the labels, all the social constructs that we give our resistors. And you'll see that there's this 1 meg footprint. We're gonna go ahead and put our resistor in there. Make sure it's nice and close to the board, and then we fold the legs over. Right, and you can see it's not interfering with any of the other holes. Like if I had it over here, I would expect that even me, that was a terrible sentence. I would expect myself to mess up this solder job right here. If the leg was covering it up, this would cause the solder to flow over the other hole. So just keep the legs away from the other holes, and then we can do the second resistor. If you don't feel confident about this, you can of course do 1 resistor at a time, but if you're following along at home, 2 resistors, it's not super complicated. So we've got the legs. I did this fancy V shape to keep the legs all away from the other holes. You can, just before committing to this, you can see kind of where the resistors are. Again, they're next to the 1M symbol. And if I'm going slow here, it's because this is a somewhat harder project. So I'm just trying to make everything as explicit as possible to make sure that none of you at home make a mistake and your project doesn't work, because that's sad for everyone. I want you to succeed. I want your project to succeed. So tinning it again, mostly just because I've left the heat on while I was talking, so the solder got a little dull. So again, place the edge of the iron against the joint that we're going to solder, and then we just give it a little kiss. You saw that the solder didn't quite want to go on the edge. That's because my tip is old and it didn't tin correctly. So again, apply heat to the joint, and then do that. Kiss the solder to the joint, apply heat to the joint, kiss the solder, apply heat to the joint, kiss the solder. There we go. Let's take a look at these connections. If my camera will focus. Okay, it sometimes is easier to tell what your joint looks like if you just bend the legs away from the circuit board so they're like flying up in the air there. It's a little bit easier to get a good view. Just double check. I've got these lovely Hershey's Kiss shapes coming out. Those all look like good joints to me. Just to be on the safe side, we'll look at the other side, and it looks like the solder has indeed traveled all the way through the hole, except on there. It's not so bad. Okay, we'll use our snippy snip to cut away the legs. Looks like one of them came on a ride with us. They kind of get sticky because of the flux that's in the solder. Okay, looking good. Now we're on to the 1K resistors. This is the most common resistor on this project, so pretty much everywhere that's left is where we're gonna be sticking a 1K. So again, bend it over like this, look for the line and put it through the little hole. Maybe maybe going this way. I'm trying to follow my own advice and keep the legs away from other holes. That should be fine. It's not, you're not going to 100% be able to avoid this, especially in other projects that are maybe more densely packed. But you know, it's just good to be careful to notice when you're in a dangerous territory, when there's a lot of pads really close to each other, a lot of holes rather really close to each other, knowing that that's somewhere that you could possibly make a mistake. That looks good. We've got one more. Bend it over. Stick the legs in the little holes. I hope this is still in focus. It's kind of hard to tell when I'm looking at the board. Okay. Apologize if it isn't in focus. I'll try and catch that as much as I can. Okay, this one is that kind of tightly packed cluster of holes. I think what I'm going to do, strategize. I'm going to send it in that direction so that the solder kind of doesn't, and maybe even go this way too with the other side so that the solder doesn't travel onto any of the adjacent pads. I hope. This is, see, it's still a little bit close, but if we're just extra careful soldering this joint, we should be able to avoid getting any solder over there. So, tin the tip. It's better to tin your tip and possibly waste some solder than to have a tip where the solder isn't molten and to heat up your pad and possibly ruin a part of your circuit board. Okay, so let's start from this side. Go here, heat up the pad, heat up the joint. I keep switching which word I use for this. Heat up the joint, kiss the solder. And you'll notice that I actually turned my iron to a place where I noticed that the solder was still molten, a shinier part. And that can actually, just adding solder will actually help keep your tip clean. So heat up the joint. See that belly? It's like the solder is only really hanging out on one part of my iron. That's fine. We'll just be strategic. Use that area to solder with. And then once we're done with this, we'll clean it more thoroughly. That didn't hold. So heat up the joint. There we go. Heat up the joint. Something that can actually help, which I didn't mention, avoiding the sort of dull solder tip where the solder's only hanging out on one side. So if you just leave a whole big thing of solder on there between sessions where you are using it, so just leave a blob on there while you're not using it, and that way when it heats back up it'll already have some molten solder on there. You'll of course have to clean it again. Again, if you don't understand this stuff, don't worry about it. Just do as I do and all will be good. So using the snippy snip. If you've got skills like me, you can snip 2 at a time. Skills and no social life because you're too busy working on sense. A wise friend of mine once said, there will always be another party, but eventually we're going to run out of solder. So, words I try to live by. Now, let's take a look at these joints just to make sure everything's looking good. Yeah. Again, Hershey's Kiss shape. Some of them are slightly larger than others. That's totally fine. As long as they're not touching another pad that they're not supposed to, we're gold. Okay, so we can solder in our capacitor now. There's this little square, maybe I guess an oblong. No, it's more of a square. It's a rounded square, labeled 10 nanofarad. 10 NF stands for nanofarad. So with the capacitor goes in the 2 legs, the 2 holes that are inside of the square, right? So you can see the capacitor's shape mimics that of the square. Fold our legs over, I'm going like this to avoid any nearby pads that could accidentally accumulate some solder. Let's take a look at our tip. Yeah, so it's got some black, but it still is quite molten. Oof, crackled there. Yeah, that's looking much better actually. Okay, so here I've got to be careful not to get solder on this joint, so I'll kind of go a little bit further to the left. Heat it up. Kiss the solder on. Heat up, kiss the solder. Bend up our legs. Be careful because the legs can still be hot after you solder them for a couple seconds. So just be careful not to burn yourself. That's never fun. Do it all the time. I've got old man hands already from soldering. Looks like some nice little joints. Okay, so if that was already stressful for you and you feel like you've climbed a huge mountain, I would suggest just taking a little break before this next section because we're getting to the advanced stuff. So go ahead, eat a sandwich, get a drink of water, you know, it's all good. The video will still be here when you get back. For those of you who are ready to continue on, we're going to start out with this longer silver shape. Comes in this little Mylar baggie, and I like to reuse these baggies because I'm a hippie and I hate throwing things away. It's not I wouldn't suggest saving all of these, but for some reason I do it. So we've got this wonderful light emitting diode here. You'll notice that if we look at these legs, one of them is short and one of them is long. The short one is called a cathode. You don't need to know that, but what you do need to know is that the short leg goes to this side. Okay, so see, it's labeled LED, and then this circle right next to it. Amazingly, the LED footprint doesn't come with its own label, but LEDs will only work if you put them in the right direction. Okay, so this short leg goes to the side marked with that little minus sign. You see that? Let me try and focus this a little better so it's completely clear. LED short leg goes to the minus sign. If your project is not working, I would say that this is a large chance that it could be this problem. If you want to verify that your LED is in the right way, it's kind of hard to show on camera, but you can actually see the right side of this LED is flat. It's really not showing up very well, but trust me, in person, it's a lot easier to tell. Right side of the LED is flat. Not only that, but you can actually see inside of the LED, and you'll see that there's a big wedge and then there's a small wedge. Now the side of the LED that goes towards the minus sign is the big wedge. My camera ran out of room. I made some more. Now we're back to soldering the LED. So we've got, let's move this leg a little bit. We bent the legs so that they wouldn't interfere with any other close by pads. Let's kind of make that shape maybe. That ought to give us some room to solder. Again, the short leg going towards the minus sign. Can't stress that enough. Your project will not work unless you get that right. If you're at all unsure that you're doing it correctly, go ahead and send me an email. I usually get back to people pretty quickly, unless, you know, I've been abducted by aliens or something. So we're tinning the tip. Same process as before. You're familiar with it by now. Heat up the joint. Kiss the solder. Heat up the joint. Kiss the solder. Don't literally kiss the solder. It's poisonous. I mean, you know, you'll probably live, but not, you know, not with all of your teeth and brain cells. Okay, so snip off the little legs on the end. Got the nice Hershey's Kiss shape. LED is close to the board, so it's not going to wiggle around. Perfect. Now we get to open this wonderfully mysterious little square. Looks very professional, I know, but it should provide all the protection you need, especially because the chip inside is also mounted to static resistant foam. So even on the plane ride, the static should not cause any issues for your chip. Now, I love these little chips. They're white. You don't get to see that very often in the electronics world. And they do so much. I mean, to be honest, they work. They're funky, you know? That's why I like them. They're a funky chip. Everybody uses the same, like 3 or 4 chips to make their VCAs, and I just love these chips because they're weird. So if we look here, you'll see that there's this little circle on one of the sides. It's hard to get it to show up except in the glare from the light, but that circle right there notes the first pin. So they label that pin 1, and pin 1 always goes towards this little semicircle at the top of the chip. Okay, so this pin right here that I'm pointing to is pin 1, where that circle is. All right, if you're at all unsure, you can look and you see the F. I'm pretty sure that's for Fairchild. That is on the opposite side of the board from pin 1. Okay, again, your project will absolutely not work if you do this in the wrong direction. So pin 1, where the tiny circle is that I'm trying to get to glare, pin 1 goes towards the top of the board. So if I was to compare it to one of the jacks, pin 1 is facing the CV labeled jack on the board. And just so you can see it in action, right there, pin 1, the name of the chip, the semicircle underneath, facing CV. If you're able to read the board, right, so the board isn't flipped over and you can't read it. If you're able to read the board, pin 1 is towards the top of the board. I cannot stress enough, if you do this wrong, your project will not work, and I won't be able to help you if you do this wrong. I've just told you 20, probably more like 30 different ways to verify that pin 1 is in the right place. If you do it wrong, I'm sorry. You screwed up. So, got our solder. This is how I like to solder chips and just sockets and things that need to stay on the board where you have to solder multiple pins. If you place it against the table, oh, look at that. Your chip is basically flying out of the socket. And if you solder it in, it's going to be sitting up here like this, looking like a doofus. So what I do is I hold the top of the chip and the circuit board in one hand so I can just kind of apply a good amount of pressure to the chip. You don't have to, flex it or anything, just enough to keep it in place. And then just tin my tip really quick. You'll notice that over time, the tip needs less tinning. That's because as you use the soldering iron, it kind of gets more used to being used, if that makes sense. It's not a scientific way to put it, but so I'm just going to grab one of the pins in the corner, and we solder it there. Now you'll see that the chip isn't going anywhere since it has one pin in, but it's good to just solder in the other side, also applying pressure, because if not, you can possibly solder it in and it would be kind of crooked or something. It just doesn't look as nice. So again, before we go any further, we're just going to double check that pin 1 is there, because after this it's much harder to redo this. Just make sure that the pin is the chip is nice and flat against the board. We're all good. Now we can put it against the table and solder the rest of the pins as normal. So just kind of these pins are lovely because we don't need to chop them off with anything. Got the nice Hershey's Kiss shape. Sean Connery is the voice actor I had to hire. It's where all of my funding goes, is to paying Sean Connery to do my DIY videos. Anyways, before we go any further, you should just double check that your board looks like this. Pin 1 facing CV. Your resistors are all in the right place, facing. They could be swapped around, but they're facing, they're going between the right pins. Capacitor at the bottom. Big pink LED at the top, looking nice and pretty. And nothing on the bottom, no pins kind of touching each other accidentally. You know, sometimes when you solder, as I said before, pins can go across. Like if they're close together, it's easy to get solder to kind of bridge two pins, and that will cause things to not work, you know, most of the time. It's good to avoid anyways. Now we've got our little audio jacks. They have 3 legs. You'll notice that the board has 3 legs, and the socket, the jack, the hole in the jack faces the outside of the board. Otherwise it would be kind of awkward to patch into, you know? So I'm just going to go ahead, place those in, et voila. Kind of push them in, make sure they're nice and flat. Okay. Now, these are slightly larger pieces of metal that we're trying to solder together. So I'm just going to go ahead, turn up my iron a tiny bit, not a lot. You don't have to turn your iron all the way up. In fact, I would say you probably never in your life will have to turn your iron all the way up. Okay, now we do the same thing here. Because the jack pin is nice and flat, we can put our iron all the way across and just get solder to flow all over that joint. Just get it everywhere. Yeah. Filling up the hole where the jack is. It's just a nice way to know for sure that you're making a good connection. If there's slightly less solder in the hole, here I'll try and give you an example. Oh, no, that one filled up. Let's try this one. There's slightly less solder in the hole. This isn't a great example, but if you just have like a tiny bit of solder missing on like the left side right there, but the right side is making a good connection, I wouldn't freak out about it, but just to be safe, you can fill the hole with solder. I usually do them all in one direction, and I rotate the board, do the other ones. Okay, now basically look at these pins the same way that we did the other ones. They've got that little, so we've got the pins, they kind of look like the same. We can verify them the same way as before. A little Hershey's Kiss, but elongated, so maybe like a Hershey's Lick. Avoided a Freudian slip earlier about that. Okay, this is what our board should look like. Now we're at the final stage, the fun part. We get to add the acrylic backing. We'll take our little standoffs out. Now you'll notice with the standoff, there's one side that's got a more angular, almost like an arrow shape, and then there's one side that's a softer, rounder shape. We want the round side to go through the circuit board. Makes that satisfying snap. It's really the only reason I use these standoffs is for the snap. Then we got our acrylic backing. We'll just go ahead and make sure it lines up with all 4 holes before we start putting it in there. Now what we don't want to do is apply all of the pressure to one corner at a time. You see, like I'm monkey wrenching this entire thing, just throwing it all over there. That'll potentially crack this part of the acrylic backing. They can take a lot of force, but you know, not full human hand strength to one corner force. So what we like to do to even out the pressures, we just take both sides and kind of like an ocarina, we just hold it, snap them both in at the same time. Snap them both in. You'll see that the standoff doesn't go all the way through, but it still totally will keep it in place. Applies a nice amount of pressure. And yeah, doesn't that look nice? A little 0 HP VCA / AND gate. All ready for you there. I bet you feel great. I feel great. I feel great when you make things that help you make music and are proud of yourself, because I'm proud of you. Proud of you, Internet. And 0 HP builders out there, go get them. Go take the world by storm with your modular 0 HP modules. If you have any questions, I'll have a link to a forum where these things are often discussed below. You can also contact me through my website. Again, if you're at all unsure about something, it's better to ask too many questions before you make a mistake, rather than making the mistake and then spending a whole bunch of time trying to undo it later. The whole measure twice, cut once thing definitely applies to electronics as well. So don't be afraid to contact me. I'm happy to help anybody out. And if you want to go through the forum, you'll probably get an answer to your question a lot quicker, because there's people out there who just like to help newcomers for fun. Of course, if you build it and it's not working, contact me and I'll try my best to get you sorted out. There's no guarantee that this is going to work. That's just the nature of DIY, unfortunately. If you feel like I could have made this video better, or if you felt like this video was helpful for some reason, please give me a comment below to let me know either how I could improve or what you appreciate about it. I know that I blab a little bit, but it's because this is unscripted and I just want to give you as much information, too much information even, to make sure that you build this correctly. So, yeah, I guess that's everything. Thanks a lot for watching and have a wonderful day with your new 0 HP mod.